So just as a quick review of that, right, we know how to solve problems like, let's see if I can find, yeah, here we go. We can solve problems like these, right? We've solved these before. Specifically, I'll zoom in on like this one, for example, right? 9 to the 2x equals 27 to the x minus 1, right? We solved this exponential equation, and because both 9 and 27 are powers of 3, we could rewrite 9 is 3 squared. We could rewrite it as 27 is 3 to the third. We simplify those exponents, right? 2 to the 2x equals just 4x you multiply when you have power to a power. 2 we multiply as well, but distribute. Excuse me. And then once your bases are equal, then your exponents must also be equal. And so we just set 4x equal to 3x minus 3 and solve from there to get negative 3. X equals negative 3, right? But supposing instead we have something like four to the x equals 11. Oops, and I'm off the screen. There we go. Suppose you have something like this. Solve 4 to the x equals 11. Can we get a common base here? Is 11 a power of 4? No. Okay? Now we could rewrite 4. We could rewrite 4 as a power of 2. We could make it 2 squared, so it would be like 2 to the 2x. But can we write 11 as a power of 2? No again. So up to this point, right, or at this point in the past, we would have been stuck. But we have logarithms. Okay, we have logarithms. All right, we have logarithms. So what logarithm base should we use if we want to cancel out this log that has this exponent here that has a base of 4? Yes, we want to do log base 4, okay? Since our exponent here, 4 to the x, since we want to cancel out this base so we can just have the exponent there, we want to use log base 4. So you want to match the base of your log to the base of your exponent. So we're going to do log base 4 of 4 to the x. And of course, since we're in an equation, when you do the log of one side, you have to take the log base 4 of the other side. So we're also going to have log base 4 of 11. Okay, so we're also going to have log base 4 of 11. Now, this left-hand side simplifies some more. Remember that when we have log base 4 of 4 to the x, this is asking the question, 4 to what power gives us 4 to the x? The x power. That's exactly right. So we could simplify this right away just to x. And so that then x is equal to log base 4 of 11. Okay? So we could just evaluate this like a normal logarithm to say 4 to what power gives us 4 to the x? It's x. So this thing simplifies to x. Okay? But maybe you'll say, Mr. Whitmire, we also have a property of logarithms here. Do we also have a property of logarithms where if we have an exponent inside of our logarithm, what do we do with that exponent? Bring it to the front. So let's do that way too. We can think of it that way. What is log base 4 of 4? Or in other words, what power of 4 gives us 4? 4 to the what? 1. And so we have x times, this is just 1, so it's just x. Okay? So you can think of it either way there if you want. You can say log base 4 of 4 to the x. 4 to what power gives us 4 to the x? X. Or if you use the property like Jake mentioned there, bring the x out front and say log base 4 of 4. 4 to what power gives us 4? It's just 4 to the 1. Either way, you're going to end up with just x here. It cancels out. Okay? And so we have x equals log base 4 of 11. Now, that might not be very impressive to you because when you look at that, you're like, okay, that's, I guess, an answer, but how the heck are we supposed to like maybe check that here, right? Like, what does that equal numbers-wise, right? Because we don't have a log base 4 button on our calculator. Some of you guys have the calculators that allow you to do logarithms of other bases. And for those of you that have those calculators, I'll show you here real quick. It's, you guys, just so you can see how to get that. Okay, so for those of you that have these kind of like nice newer calculators, if you turn on your calculator and press the math button, and then arrow all the way down, you'll see this command right here, log base. If you hit enter, it has a pretty type on, you'll see that I can like put in numbers there. So I can like literally type in log base 4 of 11. So I can put a 4 here and 11 here, and hit enter, and there's the decimal, 1.729. So that would be like about 1.730.
And if you just type in, put math, and then you go to alpha, put math, alpha, math, it goes right to just like the alpha.
Oh, yeah, alpha, because it's because of the A. Yes, yes, exactly right. You can skip down to it if you want to that way as well. So, yeah. But either way, so you get about 1.730. And if we type in 1.730 here, 4 to the 1.730, so you get pretty close to 11 there. And again, it's not quite exact because we didn't get the exact value. If I had done, let's see here.
That works out the whole thing, and then
Yeah, it does. If I have log base 4 of 11 and then I do 4 to the answer, which is like it uses the previous answer. If I hit equals, then it's like exactly 11. It just gives us the exact answer. Okay. But what about those of you folks that don't have that available on your calculator? What do? Do you just are you stuck? You're just done? No. So there's something you can do here to evaluate this. The problem with this logarithm is that our calculator, by default, has regular log, which is log base 10, and it's got natural log, which is log base e, right? It doesn't have a button for log base 4. Again, some people have the command where you can change it to log base 4, but right now, most of you guys have log and natural log. So how can we fix that? Well, it turns out that log base 4 of 11 is exactly the same as log of 11 over log of 4. This is called change of base. Or you could say that log base 4 of 11 is the same thing as the natural log of 11 divided by the natural log of 4. Okay? And so for those of you that only have the log button or the natural log button on your calculators, that's how you can evaluate log base 4 of 11. You take the log of 11 divided by the log of 4, the bottom number there, right? Or you take the natural log of 11, the big number up top, over the natural log of 4. That's how I kind of remembered it, just kind of positionally there. And sure enough, if you do that, I'll show you here. Okay, there's log base 4 of 11. And let me show you log of 11. Close that parenthesis, very important, divided by log of 4. Same decimal. Or natural log of 11, close that parenthesis, divided by natural log of 4. Same decimal. Okay, it's all equivalent. That's called the changing the base. Changing the base. Okay, the base of the logarithm was 4, equivalently log base 10 of 11 over log base 10 of 4, or equivalently log base e, remember the natural log is log base e, so log base e of 11 over log base e of 4. Okay, so question? All right. Now, so there's our answer right there. Okay, so we started with 4 to the x equals 11. We did log base 4 of both sides to cancel it out, and we ended up with this. Approximately 1.730, or precisely log base 4 of 11. Okay, so any questions on that? Questions on that? All right, let's try another one then. Let's just try another one here to make sure we're okay. Let's do this one. Okay, so let's try 7 to the 9x, 7 to the 9x power equals 15. 7 to the 9x power equals 15. Okay, what logarithm should we use here? Log base what? 7. Yep, our exponent is 7, so we're going to use log base 7. So we'll do log base 7 of 7 to the 9x equals log base 7 of 15. What will this left-hand side simplify to be? Not x, not just x. 9x, right, because the entire exponent comes down. So it's actually just going to equal 9x. And again, that's equal to log base 7 of 15. Okay? Are we done? What do we still need to do? We have to divide by 9. Divide by 9. And then we figured out, yeah, we do that, yeah, that gives us then what x will be. So we have log base 7 of 15 divided by 9. Log base 7 of 15 divided by 9. Okay? Now, let's get that as a decimal. For those of you that have the nice calculators that can do the log base, it's very easy. You know, we'll just type log base 7 of 15 and then divide that by 9. Make sure you have the divide by 9 outside the parentheses. And so you get about 0.155, we'll say. I like to do 3 decimal places just because the more accuracy you can provide, the more precise your answer will be. Okay? I gave it a squiggly equal sign because it's that shows approximately equal to. Alright. Let's see what else I want to say here. Oh, right. Of course, for those of you that don't have the graphing calculators that are nice like this, we'll do change of base. So we can either type it as log of 15 divided by log of 7 divided by 9. And you get your answer. Or you can use natural log. Natural log of 15, the big number, divided by natural log of 7. Oops, I forgot to close my parentheses. That was a big no-no. Log of 15 divided by natural log of 15 divided by natural log of 7 over 9. And then it works that way too. You can see all three are the same. All three are the same. Okay? All three are the same. Okay? Alright. So, there's that. Okay, let's try one more here. So we've got 4e to the negative 0.3x minus 7 equals 13. 4e to the negative 0.3x minus 7 equals 13. Okay, so let's see here. I see e, right? And so let's see here. E is canceled out by natural log, right? So should I go ahead and just take the natural log of both sides at this point?
Yeah.
Not yet. What do we need to do first for our first step here? What's the first thing we should do? There you go. We got it. We got to isolate the exponential. Here in the example we just did, the exponent was already isolated. In the very first problem we did, the exponent was already isolated. Here in this one, the exponent's not isolated yet. So we've got to get by itself first. As Greg said, we're going to add 7 to both sides here. So I'm going to put a little star here and say that. So isolate the exponent. Okay, super important. Isolate the exponent. Get the exponent by itself. Then take the natural log, or then take the log. Okay, so isolate the exponent, then use a logarithm. All right, so we get 4 times e to the negative 0.3x equals 20. Are we ready to take the natural log now?
Yeah.
Not quite. We haven't quite gotten the e by itself. What's still? Divide by 4. That's right. Yeah, almost. And technically, Greg, we could still take the natural log at that point. You're not wrong. It would still work. It would just require a bit of a different kind of steps here. But I like to isolate the exponent first. So you're not wrong. That one, we still could have done it. It would have worked. But it just would have been a little bit funkier. That's all. Okay. Now we've got the exponent by itself. Now we're going to take the natural log. And again, we use natural log because natural log cancels out e. And so we're left with just the negative 0.3x equals natural log of 5, whatever that value is. Okay? And then what's our final step at this point? To get the x by itself. What do we need to do here? Multiplying by 3 wouldn't cancel out 0.3. Nope. We have negative 0.3 times x, so we should do what? Divide both sides by negative 0.3.
0.3, that's not, it's like, can you rewrite it as a fraction?
Yes, what would that be as a fraction?
And then be 1/5.
So,
3/10.
what's that?
3/10.
Yeah, so which one is it? 1/3 or 3/10?
3/10.
Yeah, it'd be 3/10. Which then, as a to get rid of it, it would be 10/3 by each side, right? Because that's reciprocal. So, all right, good thinking though. And so x is precisely the natural log of 5 divided by negative 0.3, or approximately, because again we're going to get some decimal for that for certain. Natural log of 5, close the parenthesis, divided by negative 0.3. And you get about negative 5.365. Okay. And so there's our answer approximately. All right, questions on any of that? All right, I want to show you one more little thing here, and I hope this doesn't throw you off too much, but this is to help those of you that maybe don't have the calculator like I do that has the this nice log base thing. If you want to try and avoid using change of base maybe, it turns out that you don't have to match your logarithm. You don't have to match your logarithm base with the base of your exponent. So if we go back up here, for example, actually let's go back up to the first one because it's a little bit easier. We have 4 to x equals 11. So let me just show you here. Before, when we solved 4 to the x equals 11, we did log base 4 of both sides, which makes sense, right? Because log base 4 and 4 to the x, they cancel out perfectly. All right? And we then had to evaluate and got log base 4 of 11, which we use our calculator to get that. And again, if you're comfortable using just the change of base, use that. That's fine. Just do that. Okay? However, it turns out we don't need to use log base 4 here. You can actually use any logarithm you want. So let me just try it with a normal just log. So let me just take log, which is log base 10, of both sides here. Okay? Now, log of 4 to the x does not straight up cancel out, but x is still my exponent here, and it's still got a logarithm here. So what can I do with this x? By using the properties, I'm allowed to bring that x out front. Even though the bases don't match, that's okay. We can still bring the x out front. And now I have x times log 4, and it equals log 11. How can I get to x by itself? Divide both sides by log of 4. That cancels, and I'm left with x is exactly log of 11 over log of 4. Okay? Which is exactly the change of base, without actually having to remember the change of base, so it just ends up happening naturally in your problem. And so we know that's going to equal approximately 1.730. And it does. It's the same thing. Okay? So, for those of you that don't have that nice logarithm command on your calculator, you can use any logarithm you want when you want to solve an exponent. Okay? But you just got to be a little more careful. When we match the base to the base of the exponent, it perfectly cancels out and leaves just x. When we don't match, so here it's log base 10, right? Log by itself is log base 10. When they don't match, then the log and the 4 don't perfectly cancel. The x comes down out front. We have x times log 4. We have to divide both sides by the log 4 to bring it over, and then we have this division, this quotient there, which is still equal to the same answer. Okay? So you can do it either way you want there. If you don't have to do a change of base, then just use log 10 or natural log. If you don't mind doing a change of base, then match your log base to the base of the exponent and solve from there. Okay? So that's the idea. All right, that's the idea. And I think we'll stop there. I'll give you guys an opportunity then to get started on your assignment. Okay? That's going to be it for today. And then tomorrow we'll look at solving equations that have logarithms already in them. Okay? So again, your work's going to be from the green book.